That's what we are going to see today. Okay, then when we talk about navigation of autonomous vehicle, we will come across, definitely we are going to see, because this is only introduction we are talking, but when you want to pursue more on it, each one what we talk, sensors is a separate area. You may be developing sensors, you may be developing the controllers, correct? Or you will be developing data processing, like image processing, depending on what type of sensor you're using. Already we saw that camera, radar, lidar, using point cloud or camera, using various algorithm, vision processing algorithm, identifying traffic signal, road signs, then accordingly generating control signal, correct? That is another next step, correct? First identify this one, then you generate control signal by controlling engine, steering system or brake, whatever it may be, that you will do that. But before doing that, another most important thing is finding the path. Correct. There are two things are there. One is path planning, and another one is actual vehicle control. That is done using steering control, brake control, as well as the accelerating, decelerating. So when we talk about navigation, when we say navigation, these are the important differences. There are many definitions, most important, because there are many things, everything we can do, but this is important. One is called a perception. Perception is the ability of the autonomous vehicle to collect information and extract relevant knowledge from the environment. Right? What is the environment? Road. If I talk about road vehicle, we are talking about truck, bus, all this. Definitely, it can travel only in the flat road. It cannot go in any other over water or over mountain, uneven terrain, all those things that are good because they're wheeled vehicle. Correct? If it can be off-road vehicle like army tank, all those things, they may go uneven terrain also. They need not be, but since we are talking the environment, nothing but the road. On the road, the vehicle has to see. If you are driving, please know the autonomous vehicle is going to drive itself by reply human. If human is driving, as I told from many classes, you sit inside the car, take the driver's seat, and immediately won't start the vehicle and start accelerating. All the things won't do. There's a particular sequence you do it. That's what we have to mimic. Autonomous vehicle, we are going to mimic a human driver. Okay. So, but what human driver does? Start the before starting engine, you will see that vehicle is in proper location, correct? Handbrake release, all those things. That is all these things will be checked by even autonomous vehicle. Please note that. Now, once you start the vehicle, definitely check whether the vehicle is neutral gear. After that, you start your vehicle. Immediately don't accelerate. You look around through the front mirror, correct? Window, front window, correct? So this, you look at the environment. You see whether vehicle can move forward or reverse. If you are in a parking lot in front of you, there's a wall, you have to reverse. So you put the reverse gear, you will reverse the vehicle, right? And while reversing, also you look back, whether you should not go and hit some vehicle, all these things. Then once you are there, then you may turn your vehicle. Okay? While reversing, you may turn it. Then you look at the road again. See, please note that you are always monitoring the environment, correct? Using your sensor. Which sensor? Eye. In driving, 90% of work is carried by sensing the environment using eyes. Correct? Rarely use sound using ears. Somebody is coming, you want to lane changing, all these things. If you don't watch the neighboring lane, just to change your vehicle lane changing, the vehicle coming behind in the next lane may give you a horn. Right? Otherwise, 99% it is always based on the vision sensor. Okay, so that means you have to scan the environment and from the collect the information and extract. Correct. First, please know the eye is that's a sensor only. Correct. It collects the information about the environment. It takes a photograph, literally like a photograph, frame by frame. It is continuously going to send the frames to your brain as an electrical signal. Okay, that is called sensing. Your eyes are just sensor, they can sense only. They don't know what is road, what is signal, what is your, nothing it knows. All these things are done by perceiving. Perception is done by your brain. Inside your brain, already you are programmed, correct? You teach the brain from the childhood and built in there's a computer, correct? Which inside individual neurons, they are going to do all the calculation, connected this one. That's how it works. So that's what you're going to do. So first thing is perception. First thing, autonomous vehicle has to look around the environment, collect the information. from the information, it has to perceive the objects. Where is the road? Where is the lane marking? Whether in front of there's a empty road or way human is traveling. This all these things. Whatever you are doing, they call perception. Next, in the perception, there are two things. One is called environmental perception. Developing a contextual understanding of the environment, such as where is the obstacle located, detecting the road signs or road marking, lane markings, and categorizing data by the semantic meaning. Correct? You say that in front of you some obstacle is there. What type of obstacle? Whether it is a car, vehicle, whether it is a moving vehicle or a stationary vehicle. If it is a stationary vehicle, the what? Whether truck, bus, motorcycle, all these things. Then instead of that, it may be a human pedestrian crossing. Correct? You perceive what is speed, whether a small boy, kid, or your old man, or this one. Please know that this is where the main issue. Correct? Kids will sometimes try to cross the road. Correct? They will come, suddenly get scared, they run back. They do all those things. So, as a human, you know that. Correct? Kids can do all this stuff because they don't know this. They're young kids. Correct? Old person cannot suddenly run. He'll be walking slowly only, even if he sees your vehicle. Correct? By mistake, he entered in the road. He cannot take. He knows that you are coming, but he cannot run because he's old. Right? So all these things, this kind of decision taking only now it is still pending. An autonomous vehicle, they call human intelligence. This by learning, but then by seeing his face itself will say. Correct? Sometimes I have come across, I told you many times, when somebody they'll enter into the road, sometimes they'll try to come and go back. You don't know whether they are going to enter cross. Where there is a road signal is not on highways. Correct? Those things and all is the critical thing, which is the deep learning, all those things. By seeing the face, you will decide whether this fellow will cross or not, whether run or not. That by experience, the computer till now what AI could not do. This is what now become a challenge. By facial expression, correct? Facial, so somebody just smiling at you, correct? Because you would have seen, correct? When you are coming to, let's say, some 60, 70 km speed, somebody will try to do, he will just smile at you, correct? From that, you will take a decision, correct? Whether you will cross or there's no concrete. These are things which need to be done, correct? So that knowledge only now we have to deep learning, all this thing comes into picture. Facial expression and his gestures. Sometimes, no. So you would have seen in highway when you are going 60, 70 kilometers, when you cross small bridge, people show a hand and just run. Showing hand, they run in the diagonally across. Correct? Even if you apply brake, go and hit. He thinks that correct. You show your hand like a god. Correct? In one hand you will show stop signal with hand. I have seen when I was going highway, around 80 or 100 kilometers in India, the one fellow suddenly there's a median in between. There were plants. From there, he jumped on the road, shown a hand like a god. Right? He asked if he can stop my vehicle. He's asking me to stop. Even if I apply brake, it won't stop. My vehicle is 1,000 kg. Inertia is the braking this, at least this one, even if I pay this one full braking. But he was few meters away. Right? So all these things we have to do in perception, you have to do that. This we have to bring, that we are not talking, we are in the beginning. That's why these are things we have to solve in future. Deep learning. Okay. Environment perception. Then next one is called localization.
Sir, I'm sorry. One question I want to ask. Basically, suppose on road, a human is walking and beside that a robot is walking. So this camera or whatever visual sensor the vehicle carries, he will be identifying that as a moving object, right, sir?
Moving object, that is what type of sensor we are using.
Suppose
if you use a high resolution camera, correct? High resolution camera, then you can find the difference, correct? Template matching, all those things. That's what he's telling you. That knowledge amount of knowledge is needed.
So you have told that it will match with the template and then we will decide what type of object it is.
Yeah.
But practically it's impossible, sir, because there will be so many varieties of the thing that will appear on the road. So do we need to put all the template?
That's what deep learning. That is RL, reinforced learning. Many. That's what the problem. Huge amount of data training. Please note that humans just do it. That is the beauty of human brain capability. Right? We teach basic things. After that, you learn yourself. Now, the deep learning, that was this one. You won't teach by giving instruction, learn. Then you have to put millions of different pictures, as you told, templates. Not possible. But now, going to deep learning is, we are called reinforced learning. All those things is going towards like human brain. With limited knowledge, by your own experience, by own this one, you learn, update. Correct? With a human or a robot, all these things. Basic now from that. That is understanding itself is a big problem. How the brain works, still nobody knows exactly how it interprets. They all guesswork only. Neural network, deep learning, RL, reinforced learning, all this is guesswork only. But it works closer to, based on how the brain works, they learn. Okay. Then next definition, what you see, localization, ability of the vehicle to determine its current position with respect to the environment. Correct? As the vehicle, if you are a parking lot, by using your eyes, you look around, you know you are in parking lot. Correct? Where is the exit? Where is, all those things you are doing. You are scanning, using your eyes, you scan around. Correct? Then only you start the vehicle, put a reverse gear, turn your vehicle, find the exit from the parking lot. Then road sign you see, turn left, all those things. Then you look for vehicle on the road, then merge in the lane. All these things you are doing. See, please, all these things done automatically. Nobody is teaching all these things to you. When you driving school at the age of 18, when you go, it doesn't teach all these things. Already by that 18 years, you learn many things, even before starting your learning your vehicle. Correct? So this we have to teach. So then localization, the ability of vehicle, like a human, you should know where it is, current position with respect to environment. They call localization. Then planning is a process of making purposeful decision in order to achieve the robot order. Here, robot means your vehicle. You can say that the vehicle. It can be autonomous robot. No, robots are also military purpose they are using nowadays. Typically bring the vehicle from a start location to a goal location while avoiding obstacles and optimizing for the designed heuristics. Correct? I want to go from place X to Y, from Chennai to Bangalore. Correct? You do your planning. Before starting, use Google Map. Correct? There are different ways. Nowadays, you are using Google Map. Otherwise, mentally, you would have gone through that some way. Now, you start your goal, you say 2 or 3 different routes for me to Bangalore. Correct? Via Chennai, Chittoor, something like that. Other one is Krishnagiri, Vellore, something like that. Another way. Then I decide that even before starting vehicle, you do a path planning. Autonomous vehicle has to do. If you say that you sit inside vehicle, you are supposed to give what is where to where. You have to tell voice command, something like in future. Correct? Because there's no driver. Correct? You go then vehicle, you have to starting doing that. Now you are giving for Google Map, what do you do? You put enter the starting location. You can give the GPS coordinate, name of the city itself. Map, GPS map source. Starting Chennai, I say Adayar, IIT Madras. From that I give, then GPS map gives. That is called path planning. Right? But while giving path, it has to avoid obstacles. We will see that. Then finally controlling the vehicle, controlling engine, brake, right, and steering system. That's how you do. So it starts from here. First thing, this is starting. First perception. You have to see this one. Then you have to see the environment, not only where this one, and see where is the exit, all those things. That's why I said that context, understand environment. Then localization, current position of our vehicle. Then you should know what is starting, ending, destination. Then you plan your path, which route. Path is nothing but plan, route at which you are going to. Then finally controlling the vehicle. Controlling vehicle means accelerating, diesel, engine control, brake control, and steering control. These are the things, 5 important things which you need to understand. Other than that, many things are, these are most important thing. Now, if you talk about this autonomous vehicle overview, this is the environment. Environment is nothing but where the vehicle is. Correct? It can be a parking lot, it can be a highway, it can be a village. As the vehicle moves, the environment is continuously changing. Correct? Then what do you do? Using the sensors, you do the perception. Here you may use camera, correct, or lidar, or radar, right, or depending upon what information you may use all the sensors and scan the environment. Sensor used for scanning the environment and get the data, sensor data. Please know that sensor provides only data. Converts the camera means converts the image scenery into electrical signal, already pixel. Correct? Lidar means it gives a point cloud. Radar means it gives reflector signal, correct? Those signals are sent to software, which is called perception module, correct? Please note that many of the things, whole thing is implemented as a software algorithms. Software algorithms. Perception algorithm, planning algorithm, control algorithm. Correct? That's what I told you. Whole thing is as a software. This is a hardware. Correct? So you have actuator. Correct? Actuator is nothing but your engine. Correct? Brake system or steering system. Mechanical thing with motor, all those things. That's what the control system is going to control. So you can see that from the clearly sensor perceive the environment, the arrow, the data goes to the perception system. Perception system from which the decision comes. Right? What the perception says? It identifies where is the road marking sign, what that information. It just the sensor scans the information from the sensor data. The perception module identify the different type of objects. Correct? Road signs, road marking, obstacles, buildings, whatever may be. That data comes. Based on that, planning algorithm decides. Correct? Planning algorithm job is to plan. Basically, vehicle means you have to travel from to one location to location X to Y. Which way to go, how to go, all those things. So those things are already correct. This module consists of these main important modules. Within that, inside that. Correct? Similarly, here also, perception means environment per localization. These two jobs are done by this software module, perception module. Mission planning, behavior planning, motion planning. Right? Mission planning means start location, that is called map, route planning. Then from that, how the vehicle should behave, what it has to do, correct, to move to particular, apply this one. Then actual motion planning. All these things are done by that. So accordingly, the commands will be given, correct? The motion planning, final motion planning done, acceleration, deceleration, correct, comma, braking, comma, steering. These commands are given to the control system. Control system in terms of, correct, from motion planning, these things will be executed using path tracking. To execute this, there are sub-modules, trajectory tracking and path tracking. Correct? Actual control consider two parts, path tracking and trajectory tracking. You rather different, we'll see that. Path, for example, I say that this is the location X. I want to go to location Y. Correct? I have two routes. I say A, B. This is direct, correct? So this is called as a path. That's what GPS is giving. Overall, you say Chennai to Bangalore, give a long this one, so many kilometers, thing. But you see that it is showing around 300 kilometers. But as you start, you say start GPS map, start driving. Then what happens? You will then it will be showing one small segment only where your vehicle, all those things. That is called trajectory tracking. This is path. Path consists of different trajectory. Straight line trajectory. Up to this is straight line. Then curved trajectory. Correct? Then again one more curved trajectory. Again a straight line segment. Again curved. Then there's a spline. Correct? There's a straight line. Correct? So the total is called path planning because I can use path A or path B. Inside it, there's a trajectory. Straight line trajectory, curved trajectory, spline. Correct? Basically, straight line, curved plane, the spline, something, correct? There were three types. Most important road can be that shape only, correct? So if you say, so accordingly, that is called trajectory tracking. Now the vehicle is moving here. My vehicle is moving over here. So you'll be looking only this distance, correct? Follow this. Then curved track comes. Vehicle comes here. They tracks it. This is called as trajectory tracking. Short distance, maybe some 100 meter, 200 meter from your vehicle in front of you. That is called a trajectory, correct? As the vehicle is moving, trajectory will change. The path consists of many trajectories from the starting position to destination. Okay, all those things are done by this module, correct? Control module does all those things. Then finally gives command to the actuator, engine, brake, correct? Easy use of this one, which vehicle. Then apart from that, you can see that the planning algorithm also may get data from other vehicle, not only from sensor, from nearby neighboring vehicle. Correct? This is a V2 means vehicle to vehicle communication. Correct? Vehicle to vehicle, it may be Bluetooth, Wi-Fi, something. Neighboring vehicle also may send data to the planning algorithm. Correct? You wanted to the lane change. Lane change you cannot do. Neighboring, there's a vehicle going. Your vehicle is going. Correct? This is lane 1. This is lane 2. Your vehicle is going here. Sorry, it is going here. And neighboring vehicle B is coming here. This one heading. Now you want to come here. Because you see obstacle here. Correct? You want to take. Right? That time you have to see whether any vehicle is coming in lane 2. Correct? You may use sensor. Correct? Nowadays you use a mirror. Correct? Side mirror. You have to do that, no? You should not just like this one. First you have to put the indicator. Correct? Right indicator. Switch on. It will be blinking here backside also. So this fellow can see this. Yes, your intent is come here. Correct? As you start coming here, you have to slow down. Without doing, then you will come and hit. There will be accident. Now sometimes you show a hand signal. Suppose you don't have old ambassador car, something very old car, no indicator, nothing. What you will do? You will down your window, show your hand, I am coming, please stop. Correct? You will give this indication like this. So that means you are communicating with other driver. Right? Similar to that, the vehicle to vehicle communication may be needed when autonomous vehicle is working. Similar to act like this. Correct? So see the data flow. Please take down this functional block diagram overview of the perception and path planning algorithm, overall control. Correct? Vehicle control, autonomous vehicle control overview, control system overview. I can say the vehicle control system overview, including the complete perception, planning, and this one. This is the functional block diagram. And these are the modules within that. Please note that they're very detailed. We are giving overall function only. Inside the many steps. It's not easy. It may be consist of maybe 1 lakh line, 2 lakh line of program. Many modules, all the tested, developed, all this. So each group will be doing, correct? Sensor is separate, development, this vehicle to vehicle communication module, then designing ECU, engine ECU, steering control ECU, ABS ECU per vehicle, then control algorithm, this part. Maybe thousands or even 10,000 engineers in your company may be working, correct? We don't know to develop full autonomous vehicle. Okay. Shall I go to the next slide?
Yes, sir.
Okay. Now I talked about sensing. What is sensing or perception definition? Already explained. Quickly we'll go through. So sensing is collecting the environment information using sensors. Right? So what type of sensors? If in human driver, he uses eyes, ears, nose, smell, correct? Tongue, skin. The human has 5 sensors. For driving vehicle, you need only these 2. Correct? Most of the time, eyes and sometimes ears. Correct? Nose, all those things we don't use for driving purpose. Okay? But these are sensors available. The eyes collect information reflected the environment. That see, light is reflected by the objects in the environment. Whatever you see, that object, whether wall or water, it reflects light. Correct? Shining on it, reflect like hits your retina. Then the eye generates electrical signal, transmit the data to the brain. The actual perception is called the interpretation. Correct? Design what the idea that is done by brain, not by the eyes. Sensor job is just convert the environment information, correct, into electrical signal. Correct? Even camera. In case of autonomous vehicle, you may use camera, visual cognition using camera. Okay. Light is collected by what is the information? Color, shape, pattern, all this thing can be identified by the eye. That is the advantage. In case of autonomous, this one, stereoscopic or monoscopic color camera, you need. Okay, it can do that. Experience plays the vital role in perception. Experience plays. That's what I told you. You learn from the day a baby is born, he learns. Any human or any living animal learns. Yeah, cat, whatever maybe, throughout it learns. So how good your perceiving is identifying, interpreting, or knowing what it is, what you are seeing with your eyes, what smell you are getting, whether rose or orange, apple, the smell, nose, right? That based on the previous knowledge, Correct? That's all. So experience, knowledge stored in memory, that place. So there's also more information already your autonomous vehicle control learns and stores in his memory. It can easily find out what it is, perceive and take the decision. Okay. Otherwise, misinterpretation can happen. Perception represents apprehension of the present situation in terms of past experience. Without past experience, you cannot interpret, identify. If you have never seen apple, correct? Nobody is told what apple look like, what shape, what color. If I see apple, I won't know what it is. I won't even touch it. Hey, it looks red, it may be dangerous, something. Correct? First time in your life, nobody told what apple. So experience very important. So teaching. Correct? That's what deep learning, correct? Reinforced learning, correct? Template matching, all these things are just we are trying to copy how we are driving vehicle, how we are humans are living, are moving by using sensors. Same thing we are to do. Okay. So learning and knowledge base, that is past knowledge base and past experience is an important component of perception. These are 4 important points of what perception, how it does. Already human driver ability to instantly agree relevant traffic sign, traffic light, and the likely response of other road user. That is somebody laughs at you, opposite driver. For example, cyclist will come, he may just smile at you. You won't even say that I'm going to cross. If he smiles, you know that he just give you a way. Correct? You won't even show a hand, nothing. He just looks at you and smiles. Sometimes you give way. Okay, go. You are a cyclist. You take a decision instantaneously. This decision, how the autonomous vehicle software will do. There's a program, there's a definite cyclist problem. You go and see cyclist problem encountered by the first autonomous vehicle, Google vehicle or something in Texas. One small road crossing, I told you. Correct? Autonomous vehicle, it is one cyclist came, he stopped in the road junction, something like this. Correct? Your vehicle is here, you are stopped because stop this one. Here there's a cyclist. Correct? And sometimes he tries to, but if cyclist not pedaling, how do you know cyclist is not going to move forward? If you put both the legs on the floor, the road, taking this one from the pedals, correct? You know that he is not moving. Already applied brake, stationary. Now he is not going to make. Suppose he put one leg on the one pedal. What it mean? You are trying to move forward. This fellow puts his pedal from this one. Correct? Gets ready. By seeing his face and the pose. Correct? One leg is on pedal. Automatically you will start applying brake. Okay, this fellow intention. Then he also looks at you. Correct? What you will do? You will stop your vehicle. Correct? You will apply brake. Then he will apply brake. Then he thinks that you are stopped, then you will try to move. Correct? When you like this, the autonomous vehicle, they say they should to take a decision. Autonomous vehicle took many minutes. Finally, could not take decision. Cycle put this one. They want to test what you'll do. Voluntarily, they did it. What autonomous program vehicle controller will do. The vehicle could not move not in an inch. Same location. Applying brake, accelerating, decelerating, doing all these things. But as a human driver, what you would have done? You would have taken some hard decision. You would have put a horn. Correct? Shouted at it. Something would have done. One of you would have moved. Correct? After 5 minutes. No, what I'm saying is not correct decision. Finally, sometimes something otherwise deadlock will happen. Correct? How to take decision, get angry, smile, give you a way. Correct? You yourself say go. Okay, something like that. How to decide? That is a problem. Okay. So that kind of problems are the main important in autonomous vehicle. Okay. So all that important, perceiving the intention of this one, all those things is very important. Okay. So sensing and perception autonomous vehicle, we know that we talked about sensors. For autonomous vehicle, main thing is these 4 sensors to perceive the environment. Already we know, correct? Then in perception and autonomous vehicle, we have computer vision based approaches, machine learning. There are 2 types of approaches currently used in autonomous perception and autonomous vehicle. Tesla, Google, many companies are, maybe your company also working, I don't know, right? Everybody is working. So they use this one. Computer vision based perception using explicit mathematical formulation to describe the problem and rely on the numerical optimization to find the best solution as a mathematical formulation. Correct? Everything you write as a formulas. Correct? Data, all this thing from that from even vision data, camera data, from that you do, correct? We already saw vision processing, finally take decision. In machine learning technique, neural network is used, which is called data-driven approach. This is equation-based way decision. This is data-driven neural network, just like a human brain. No equation, you learn, correct? Or do you do a calculation? You are this one. Are you writing when you see this one? Are you do a calculation mental a plus b square something? Nothing like that, correct? All based on data, previous experience, and the data is stored in your brain. From that you take decision. Correct? That is what now deep learning is trying to do. Okay, neural trying to identify pedestrian in camera will extract features that commonly present in this one training, right? Whether who is crossing, whether pedestrian, what is the shape, what is the size, what is the color, based on that take decision. I told you, correct? If you are an elderly person or a kid, you have to be very careful. Somebody pedestrian trying to cross. If it is a normal mid-size, mid-aged person, you know that he can run or you maybe take decision. Kid, correct? So then you can guess, you estimate, correct? Sometimes people colloquially say guesstimate. You guessed and guessed. That is a colloquial only, nothing like that. So whether what you will do, accordingly you take decision, whether to drive, go forward, give way to him, all those things. Driving is that only. It is not that just pressing a turn. Otherwise, you will make accident. Both the approach of machine learning and have their own merits and disadvantages. Autonomous vehicle rely on the combination of two techniques. Sorry, right? It is not that the autonomous vehicle may use only computer vision based technique or machine learning. Now they are trying to combine both algorithm also, correct? That you can do. Just now, what are challenges in autonomous vehicle perception? Perception is very challenging for autonomous vehicle because it is incredibly difficult to build a generalizable and robust model to describe complex traffic either explicitly or through data. Correct? Just now, Roshan Kumar asked how to do. Correct? How many pictures you save? Correct? Huge amount of explicit through data means taking pictures or writing as equation. This is what it. If you see this is equation you have to apply. This is what you have to do. You cannot do that. Very difficult, very complex. The autonomous vehicle can encounter strange and previously unseen obstacles also. That's what Kumar was asking. Correct? Different type of this one can be the robot, walking robot, new robot. Now robot is going to rule the world. It's a pedestrian while robot is crossing. Correct? It may be shape may be different. It may not look like an animal. It may not look like it can be 6-legged, 7-legged, 8-legged, something else. How whether it's animal or human, what do you decide? Correct? So new type of traffic signs, obstacle known. Correct? These are some examples. For example, when you're driving in your guard route, some two animals are fighting. Correct? So flock of pigs crossing the road. Correct? So birds. Correct? Here you see that horse-drawn cart is moving. Correct? So, for example, taking decision here. This is what they said. Correct? Say, for example, Halloween day. Correct? People, how do you know? Because they put a lot of costumes. Whether you tell them a human or some toy, what do you decide? Correct? But you can do as a human, you know it. This is today immediately remember. Yeah, today Halloween day. So after that we know that the humans only they put a different costume. They are not ghosts, something like that. Correct? You understand. Correct? You have to teach your autonomous vehicle also. Okay, this kind of this one. Correct? This you learn as a kid. That's what we are talking complex situation. This one, correct? Light, correct? You see that light is falling here, but here it is dark, correct? So partially written, correct? This kind of curve, this one. For example, you see that this is a truck traveling in a guard road. You can see that this autonomous vehicle can drive, but humans are driving. Afghanistan, Pakistan, or Peru. Correct? If you just want this one road, there's no road. You see the goats are there. You have to maneuver without hitting goats. Nobody is going to. You would have seen in your village road. You put a horn. The fellow who is there, he doesn't bother. He's here. He's not bothered. He just does it. It is your headache. Somehow negotiate without. If you kill one goat, over end of it. Your vehicle is stoned. You are in this one. The village will come and work. So, but still you can. But whether autonomous vehicle can drive here, like a human driver. Right? These are complex situations we are trying to say. So, perception, this is what we are trying to do. Okay. Challenges are that computer vision based perception have a fair performance and typically generalizable wide chain and conditions. Correct? We are talking about what is the advantage, the perception, computer vision based and machine learning based. Limited to based on data trained. Correct? Here you train some basic things. As I told you, you cannot show all these things. Later, the algorithm will, like a human brain, will, correct? Human means we know, correct? You see a fair complexion man, correct? Different face, correct? You see Chinese face is different, Indian face is different, American face is different. Still, you are able to identify different. Nobody is not going to tell too many things. So that you learn, correct? That is got the neural network training. This one. These are possible. From that, you interpret, okay, whether it's human or animal, all those things, or a robot, or all those things. That's what I'm saying. So this is the, here, the main thing is huge data will be there. Right? Initial training you have to do. Training using neural network. Next thing is what you call a mapping. Mapping is the present technology of perception for autonomous vehicle. Already we know that. Correct? Google Map. Correct? Road vehicle में Google Map, it is a aircraft. You know the drones, all those things. The 3D map you have to create. 3D map of the previous survey. Correct? Ground vehicle means 2D map. If it is autonomous vehicle means we are talking about drones, all those things. You need a 3D map. Correct? You fly. Correct? Already Google has created. See, the maps are Google as the map because I told you they drove vehicles. Correct? On which they put a camera, lidar, all those things. They took picture, video. For entire world, they took around 5 to 10 years, correct? Through motorcycle, small lanes, Canada, they took the video from that, extracted, collected information, tagged, correct? That's why you're getting that much. That's why you're paying money to Google Map, correct? It's not free. So much they spend billions of dollars to create the map. Actual photograph. Somebody who are driving car, put a camera on it, Google car, correct? With the government, you cannot do it on your own. You have to get the local authority, the state government, central government in your country, they do it. 3D map, put high definition maps, all those things. So you can generate the dynamic elements. There are two type of elements in the map, correct? Static element like building, trees, road, nothing is going to change. But dynamic object means animals, vehicles. Now it will be there, next minute may not be there, correct? So dynamic object avoiding is very difficult. Correct? In the map, you cannot add that. Map shows only static objects, road. Correct? In Google Map, I'll show the road only. The building nearby, all these things, nothing more than can show. Lake, all these things. They are static objects. Dynamic object cannot be. So dynamic objects, it has to be identified by autonomous vehicle software. Correct? Obstacle detection software and path planning algorithm should avoid. Correct? So trajectory planning. That time you have to avoid that. So like this one. Computer vision can be relied upon redundant perception technology and neural network and sometimes fail, correct? So one sensor alone is not sufficient, right? That's why the autonomous vehicle, you put a camera plus lidar, radar plus camera, something like that, correct? Redundancy, right? So you need to do that. So what is the localization? Already we saw vehicle localization. The definition, nothing but determining the vehicle current position in the given environment. Nothing but where I am. I am sitting in my room, MSB 311 in building mechanical science of life in IIT Madras. I can say, sir, where are you? I can say my location. Similarly, the autonomous vehicle should know its current position, maybe GPS coordinates. That is the best one, global coordinates. From that, so many latitude, this one, at this location, I am there. Knowing current location called localization. Right? For that, you can use many methods. Most popular nowadays for autonomous is GPS. Global region, it can be. But a main drawback of GPS is indoor. If I'm inside building, the GPS signal may not be because concrete obstructs the GPS. Correct? Radio signal coming to GPS satellite. If your vehicle is traveling, correct, in your road, suddenly there's a bridge. Correct? When vehicle goes inside this GPS signal, here it will receive, here it won't. GPS denied location is called GPS denied location. So sometimes the tunnel, bridge is okay. Tunnel maybe 2 kilometer, 5 kilometer, 10 kilometer. Correct? Atal tunnel in Himachal Pradesh, maybe 5 kilometer. Then you won't get the signal from GPS at all. How the autonomous vehicle will drive? Correct? Your map is not working. Correct? Google Map, when you go below picture, go signal lost, GPS signal, Google Map says, but still you drive using your eyes because that is sufficient. Only trajectory plan, path planning is not able because short distance you can see your vehicle road up to 100 whatever you use. Eye is sufficient. So you travel, then when you get the signal, you can continue. Correct? These all those things you have to take when designing the autonomous vehicles path planning algorithm. That's why you need multi-sensor, GPS plus camera plus all those things. Okay. So take the functional block diagram. So what is this? Baba. So the current location, position, right? So prediction of current position, right? So you will use map and use encoder. As the vehicle is concerned, wheel speed sensor. Wheel speed, using wheel speed sensor, you can find this is nothing but wheel speed sensor. From wheel speed sensor only you are finding how much distance you are traveled, correct? Vehicle, how much distance moved, that's one sensor. And apart from that, you use a map from your GPS, correct? This is a database. From that, correct? From that, you find what is the correct position, correct? Which is called as position, prediction of position. Current position you are finding from the encoder and also GPS map. These two data you use. Okay. Then this information also goes to matching algorithm. Okay, that is perception. Please see that this is wheel speed encoder. This is perception, observe camera or lidar. Right? So observe this data comes from this. You find out whether the current predicted position is okay. Right? You compare from these two sensors data. This is coming from your sensor. This map is already available, existing, correct, from GPS. This is the perception, your camera. These two data, from that you match. From that you find the position update as the vehicle is moving. That will be compared with the wheel speed. Wheel speed encoder also gives what distance it traveled. Together you update. Then finally this is an endless cycle. As long as vehicle, you can see that. That's why I put a endless cycle. This is starting information. These three are starting this one. From this first estimated, correct, predicted position, estimated position, and compare. Then if it is okay, then you fix the current position. As the vehicle moves, you go on updating. Any doubt here?
Sir, I'm sorry. Basically, can you explain it again, please? I'm sorry, I could not get it.
No. See, basically, localization means finding where you are, correct? So you need to find your position. To find the position, current sensor, current system, the autonomous vehicle, they are using map, correct? And that is nothing but GPS. From GPS is coming. Then your perception sensor. These two data, using that you will find the matching. If everything the current location matches with this one, the information go to position update, estimate the current location. Okay, this comes here. Then this gives what a current location, distance, or location is the as it moves. Then it will be compared with the vehicle wheel speed sensor. Then you are going to compare. Then you update. Is it matching? As the vehicle moves, you are going to update. That's see, vehicle local at any given instant, you should know where you are in the given environment. In the given environment, in this case, is on the axis. You are moving.
So basically, sensors is vehicle is being the position of the vehicle is being compared with the map.
And each and every second. That is what we call localization. Okay. That is based on where you are. Now, as the vehicle is moving, you measure how much distance travel is a wheel speed encoder, correct? And you are going to compare GPS what the current location as the vehicle. Correct? That information is coming here. You can see here. Correct? So this is the environment processing. This sensor allows to follow the path. This sensor allows to follow the path. As you start moving along the path, you are going to compare with this, find the location, you know where you are, update. That's what called localization. Finding your current position as and when with respect to time, every time instant, maybe millisecond one sampling. Okay, position estimation, correct? We talked about localization, main thing is position estimation, correct? Position estimation. For that, many methods are there. One method is called simply called dead reckoning. Correct? Dead reckoning is a very old method used to do navigation even by Greeks, Mesopotamians, Indians who was traveling. Correct? Cholas, they went up to China 1,000 years before. That time, no GPS, nothing. Correct? Even no magnetic compass was not available. Correct? They use stars, all those things. Correct? Mainly stars and some big, say, whether mountain range or islands. As they go from one island to island, that is called a waypoints. The start position mainly used for the navigation. That time there was a dead reckoning method. Determine the current position of a vehicle by incrementally integrating distance travel and the direction of the travel related to start location. Correct? So this method is you use data from various sensors. In current case, we are talking wheel speed sensor, gyroscope, and IMU for finding the distance travel and direction of travel. Okay. Dead reckoning is also a deduced reckoning, correct? Dead reckoning or deduced reckoning is the process of calculating the current position by using previously determined reference position, which is called a waypoints. But you should know the waypoints. What distance from the current waypoint already known. Somebody had traveled many times. They measure. So okay, the location X, correct? Location Y. The distance already known, approximately estimated. The distance is known, correct? From that, you want to go to location Z. The distance also known. These points are called waypoints. X, Y, Z are called waypoints. So already, if you know this, from that, next time when you go, you can estimate. Approximately, you know the distance. As accurate as possible. From that, because I want to go to this location, but I should not deviate and go like this. So the easiest thing is go from this location, this one, note. And so that if you reach that one, even if you're moving something like this, it can happen because you don't have any reference, no distance. So if you're moving, you will try to correct and try to come here, right? So error correction. Now you reach the location, at least you know that now you are on the correct waypoint. From this, you go here. Otherwise, you may drift, to go like this, or you may go like this. So waypoints is there, you will correct. Every time you go, okay, you deviated, but you try to correct and come to the location. That this location, known location, correct? This is why is known. That is, now you want to go to, from here you will go. So correct. So that is called dead reckoning. Thank you. A common drawback of dead reckoning is the estimation error increases with the distance from the initial position, so that you have to this one. Instead of going straight away from one location, correct? I said this is X, this is Y, correct? If I try to go, I may drift like this, I may go like this. Instead of that, what I do, I put in between waypoints. Right? I go here, even if small deviation, you would have deviated a little bit only. Correct? So you will come on here. From there, you go here. From here, you go here. So it is more, if you add more number of waypoints, correct? So you can course correction, like a waypoint correction. So you will not deviate, like you go finally miss the target. You may never reach that, you will be goes somewhere else. Correct? So travel. This method uses various devices, wheel speeds already we saw. The process calculate previous known this one, taking the reference position, that are waypoints, advancing that position based upon the estimated speed. Now, if I want to come from here to here, you know that if I go 10 km speed, only thing what known is that time. Dead reckoning was developed 1,000 years before, something like that. What do you know? You know the speed, approximately. So constant speed you are going, velocity, known time. So if I'm going from this distance, already you know 1 kilometer, correct? Approximately, correct? So many times you travel. Now, if you're going 0.5 kilometer speed, your vehicle is traveling, and it took, for example, 2 hours, correct? Definitely should have reached this location. Already you know this, correct? If I go 0.5 kilometer, within 2 hours you reach because the distance of 1 kilometer, correct? If you are not reached, then that means there is a problem. You are deviated from, that's how they were dead reckoning, they were knowing, correct? So that means you should not travel further. After traveling, correct? Then direction also. In dead reckoning, which direction? You are moving towards, for example, this is towards east. Your ship is moving towards east, right? In the ocean. Already people told you have to travel in east direction, 0.5 kilometer speed. After 2 hours, you reach this island. You are not reached. You have traveled not because you have the machine to show the direction north, south, east, correct? Then your vehicle speed is known. That's what you are talking, correct? Estimate. Now, if the small deviation, you correct and come back. You went like this by mistake. Your vehicle was going something like this. Right? It has not reached it. You are seeing this island. Correct? This island, there are big trees or something. What you will do? You will try to come and reach here. Correct? So that means correction has been done. Otherwise, you would have went like this. So then you travel from here. They say northeast direction, something like that. Correct? Travel same 0.5 kilometer speed. So say 3 hours, you will reach this distance. This next waypoint. So that means correction. They call waypoint correction. So that definitely you reach the final destination. The method used by dead reckoning. A common drawback is estimation increases. Instead of having, I have, for example, I have to go from here to here. I put only one waypoint. Correct? I deviated too much. Correct? So if waypoints are less, there are more chance of deviation. That is called error. Right? This much error is there. Deviation. Correct? So if I have more waypoint, deviation will be smaller. That's what we are trying to say. Estimation error increases if you don't do the course correction intermediately, short distances. More waypoints are there, this is better. That's what we are talking, right? So the frequent updates are the fixed position are not called as waypoints. If waypoints are there, it's going to be a problem only. When watching big versions, sometimes may not have, but that's why sometimes they trip. They take 6 months, 1 year to reach America. From England to this, and they take 3 months, 4 months. That time only sail ships, no? Some 300, even steam engine was not there. 1,000 years ago, think about it, okay? The errors will accumulate, cumulative, and the new estimate would be the own errors. So it will also based on previous position, okay? This method nowadays not used. This was the method. So how it works, I quickly will go through. So the positioning calculation DR is followed. The distance, see for example, see you are here, correct? And this is east origin. This is origin 0, origin, north and south. Because I told you direction and also velocity and the time. These three are important dead reckoning method. Distance travel in east direction, because you know that you are going to travel in the east or towards north or in between, anything like this. Okay. So now if you travel if you are traveling in this direction with particular velocity, you can reach any this one. You know the velocity, you know the time. So then you will automatically, if you only east direction, you have to maintain the direction of a vehicle, automatically reach. Similarly, north direction, no issue. But in between, if you need to find out the tangent, correct? The current location with respect to x-axis, with respect to y-axis. That is north direction with respect to east direction. That's why you say distance traveled in east direction, correct? EK. K represents sample, correct? At time t, K equal to, we say that, correct? So to give an instant, the distance traveled at the east direction previously, correct? I say every 1 second once I am measuring how much I travel, correct? This represents time, correct? Time sample. This one time t equal 10 seconds, I say, right? This is 10 minus 10 seconds before where you are. And with respect to east, the origin, with how much you are traveled in that direction. So similarly, north direction, how much you are traveled. Then you are traveled for 10 seconds. So you are updating, correct? So distance traveled within the 10 direction in east direction, you know that it is a planar. So we will multiply sine theta. You know the direction, vehicle, correct? With respect to this one, how many theta? Theta represents this. Already shown here. Correct? Now your vehicle is here. Correct? This is the theta. This theta is in this equation. X into sine theta. You can find the distance traveled from the origin. Right? Y into cos theta. You can find out this. Correct? Oh, sorry, this. Correct? So you find out then assume here theta of a heading angle, right? What direction? Currently, vehicle may be heading with respect to x-axis. We are talking about this y-axis, right? How many degrees it is moving. So, assuming the vehicle acceleration during the time period, sampling period is k minus 1 to k. I said 10 seconds. And the time period t. In this case, for 1 second we have taken. Correct? Easy for understanding. In this case, we can find the distance travel after that time. Distance travel after the 1 second can be calculated using this equation. And this would have studied 7th standard, something like that. If you know the velocity,
yeah, 80 ut plus half at square, something like that.
Yeah, same thing, right? Velocity into time and 0.5 time acceleration into k minus 1 into t squared, time square. So you can, this is very simple. This is what they did reckoning. Okay. So the velocity can be calculated. This equation already we know that. Finally, how do you find the acceleration? Acceleration method, sigma function. They call sigma function, sine function of the ax into root of ax square and ay square. In this case, x is nothing but east, y is nothing but north direction. From that you can find out. Okay. This is the one how they were using. Okay. The old method now nobody is using. They were used thousands of years. Right? Now, what is used for autonomous vehicle? GPS signal. How the GPS works? This is for localization. Localization nowadays done in autonomous using GPS. What is a GPS? Is a global positioning system. The short form is this one. It is developed for American defense to find the current location of soldier or a aircraft or a tank or a plane. Any army person, you want to know where he is at any given instant in the globe, because American army is around the world, correct? They have Air Force base, army bases, fighting this one different locations, correct? So they want to know. Further, they developed the GPS. After for many years it was secret. After that, they want to make money because they spend billions of dollars. By the time other people also want to develop. GLONASS is another this one developed by Russians, correct? They are given for this one. Now it's commercially available. Similarly, India also now launched their own satellite system, right? But it cannot cover entire globe. It can cover your position in the Asia, some 2,000, 3,000 kilometer radius from the India. That's sufficient to find the Indian army or this one wherever they want to. Even GPS is denied, right? So we can have our own satellite system. They want to increase. Okay, find out. So it is nothing but a network of 24 satellites orbiting that are 11,000 nautical miles in the space. Correct? They are geosynchronous orbit. That is 11,000 miles from the Earth's surface. Okay. And there are 6 orbital planes. Each orbit, you can see that is shown here. Correct? This is one orbit. Okay, in which you can see that there are 4 satellites. 2, 3, one more here somewhere. Okay, so here each orbit there are 4 satellites. Right? You can see that so that it covers. That's why anywhere on the globe GPS can see. At any given instant, 3 of these satellites, at least 3 to 4 satellites will be. You will be able to see this thing. You can receive. For example, you are standing here. Right? You are standing here, you will be able to see at least 3 satellites at any given instant. Minimum 3, up to 4. Okay, why we need minimum 3 or 4? We will say that's why they have 24 satellites. Okay, these satellites are moving at a constant speed to maintain the position. If you see the satellite, it will look like it is a stationary. We call geostationary. Always it will be visible to you. Please note that the satellite is moving, Earth is moving. Earth is rotating itself, moving around the sun. Sun is moving around the galaxy, Milky Way galaxy. Everybody is traveling, correct? Around thousands of kilometers speed. Earth is moving in the galaxy, sun is moving per second, some 10,000 kilometers it travels per hour, 10 to 20,000 kilometers, even more, correct? Exact number I don't know. Everybody is moving. So, but the satellite is moving such that it looks like it is stationary. That's why we call geosynchronous satellite. That can happen only when satellite is move to this position that 11,000 nautical miles. They call geosynchronous orbit. And the satellite should move. It has a rocket so that it is constantly moving at constant speed. Okay, so it making two complete precise orbits over Earth in 24 hours. The satellite is also moving. Within 24 hours, the satellite will make two rounds, each satellite. In a circle, there are four. Okay. Okay, hence, whenever you are on planet, at least four satellites will be visible to you. That's what I told you. You are standing here, you are going to see at least four satellites. If you are standing here, you will see at least these four satellites, like this, so that you are covered. The signal is important. Your cell phone receives GPS signal from four satellites, the minimum at any given time. That's why you are able to say your location. You click on it. Google Map, you say current position says, because any given time you are receiving signal. Based on signal, your GPS, your cell phone GPS receiver calculates and tells your position. That is nothing but localization. If you click on your GPS cell phone and say that GPS map switch on, I say current location, it is nothing but localization. It says where you are on the Earth surface. So GPS satellite transmit two carrier signal. One is L1, L2 band. Correct? They send transmit, particularly this one. It has some information that is very important. GPS satellite signal received by your cell phone. Inside that, it calculates the position by based on the four, minimum three satellites. We'll see what it is. Each satellite transmits three frequencies. One is called civilian GPS that uses L1 frequency. The frequency is this. Correct? Then GPS provides two services. One is called standard positioning service and precise positioning service. The satellite sends two signals. One only is available for the civilians. Other one is meant only for military personnel. American military, not for you. Nobody else can see it. What is advanced precise? You can locate your position 0.1 meter accuracy. But we have current GPS is, I think, 5 meter, 2 to 5 meter accuracy only it says. Correct? That is limitation. SPS, correct? Standard positioning service, positioning provides L1 frequency available to all GPS users, including you and military. The standard position, the P precise is available only for American Army, correct? Or American military, not meant for you. L1 contains course information, what is CA code and navigation message. PP is reserved for highly accurate military positioning, velocity, and timing service at broadcast and L1, L2 frequencies. There are two frequencies for military purpose. For purpose of redundancy, they are transmitting GPS satellite transmit L1 and L2 frequency, and the standard service available only L1 frequency alone. Okay, why? Even one band is not working. The military, American military should get this position, always get this signal. That is not available for you. Okay, this precision code is encrypted. So that's why even though the precision code also is coming and hitting your cell phone, but it cannot be, it is encrypted means your cell phone cannot decode. Right? The GPS receiver in your cell phone cannot decode this information. It can decode only this. That is sufficient for giving the position. Okay. Okay. GPS satellite signal contain three things, right?
Sir,
Three.
sir,
Yes, please.
sir, shall we go break for 5 minutes?
Definitely.
Okay.
Yes. Okay.
Right, sir. Sir, we can start, sir. Hello. Hello.
Hello, sir.
Sir, we can start, sir.
Yes, sir.
Sir
Yes,
is
sir.
available?
I don't know.
Okay, okay. Okay, okay. Hello.
Hello?
Sir. Sir came. Hello.
No, sir, not yet.
Okay, okay, okay.
Shall I start the class?
Yeah, we can start, sir. We can start.
Okay, the GPS sends different type of ports from which the GPS receiver estimate the current position and displays the information. Okay, so one is called pseudo random code. Okay, which contain ID of the satellite, because there are 24 satellites. Each satellite is given one ID, and that ID is transmitted by the satellite. They are called pseudo random code. The GPS receiver verifies this ID of satellite available with the satellite page, because inside your cell phone there's a GPS receiver. It has ID of all the 24 satellites, right? So from and the where the satellite number, if you know from that, automatically the GPS receiver knows the current position of the satellite, that the information needed. Then ephemeris data, correct? This is used to determine the satellite position, and this information about health of the satellite and current data time. This you don't need. This data is need for maintaining the GPS. GPS satellite maintained by a company and American Defense. They want to know what is health, whether it is working, all those things. So this data is ultimately transmitted, but that you don't need, but it transmits. Third one is called almanac data, correct? They call almanac data per this word. Each GPS receiver should at any mm, should at any time. So you know that the satellite is rotating. I told you, correct? It is orbiting around the Earth. It takes two orbits within 24 hours. So the current, where the current location in the Earth, around the Earth, that is given by this data throughout the day, and shows the orbiting for the satellite and each other, because all the transmit. But anytime I told you that your cell phone may receive from 4 satellites. For 4 satellites, what is current location each satellite, what is ID, correct? And they also send that is known. GPS receiver receives the message, save these two data, ephemeris and almanac data. This information is used as a set to the clock within the GPS receiver. Okay, so there's atomic clock in the GPS satellite. It sends his current location, time in his clock. That information received by your GPS receiver, and inside this one that clock is used for correcting the current time of your GPS receiver. That's what we are talking. GPS receiver clock is adjusted from the clock coming from GPS satellite, because GPS satellite has an atomic clock, accurate clock. Okay. So determine the current position of a person or a vehicle who is holding the GPS receiver. The receiver compares the time at which the signal transmitted by the satellite with the time it was received by the receiver. Correct? When the transmitter, the satellite transmitter time, he says that current time is 10 hours, 25 minutes, 30 seconds. Okay. Now it has transmitted the data coming from 20,000, the distance of 10,000 miles, correct? From the distance, it takes some millisecond, microseconds. It is radio signal, correct? It is a speed of light. So by the time it receives, the new time is there. That the time difference is known. That is recorded. That's what the GPS receiver does. And similarly, you find the from the data, correct? It knows the time difference. What time the GPS, for example, the satellite transmitted 10 hours, 25 minutes, say 35 seconds, and it goes up to millisecond. Correct? I say that 20 millisecond. Correct? Now, this has traveled the 10,000 miles and reached this one. By the time it reached, the already internal clock is there in your GPS receiver, right, in cell phone. It says that 10, 25, 35, say for example, it says 18. That means 2 millisecond time is taken. Right? From this, we know that it is straight line. We know the speed of the radio wave. So 3 into 10 power 8 meter per second. We know already we saw the radar, no? Time of flight technique. Like that, for this satellite, the GPS receiver calculate what is the current distance between that satellite and the GPS receiver. Similarly, it calculates for other receiver. Correct? So it need to have at least 3 satellite data. Then it is able to compute distance between this one receiver and the particular satellite, 3 satellites. Then using what is a triangulation method, the GPS can find out its current location. With minimum of 3 satellites, your GPS receiver can determine the latitude, longitude position, what is called a 2D position to fix. With 4 satellite, it can find out 3D position. Correct? Ground vehicle need 3 satellites. With airborne vehicle, 3D information need 4 satellites to find the latitude, longitude, and altitude. So if you are a drone, it need at least 4 satellite information. That's why GPS satellite, there are 24 satellites. At any given time, at least 4 satellites can be seen. Correct? Air Force need 4 satellites. Army, Navy need 3 satellites, sufficient. Okay. Okay. Now we see how it works. So the GPS sends 5 frames, correct? GPS navigation message consists of what you call subframes, correct? So this is data. TLM, how, TLM, how, TLM, how, TLM, how, TLM, how. And each subframe consists of following data: GPS week number, accuracy, health status, all these things. This data is not needed for you. Correct? What is the week number? Because it has a lifespan. From the day it was launched, how many weeks has already passed? That information is needed for the GPS satellite controllers. But this is not needed. Clock, all this thing will be done by this one. But it transmits. Then it transmits Ephemeris parameters. This also, next information also that the 4th subframe, console, almanac, and the health data of the satellite for this 25-30 satellite special messages. Finally, this also contains almanac and health data for 1 to 24 satellites. Okay, I told you there are 34 to 30. Actually, you need 24 satellites, but GPS has 32 satellites. So you know that any given time some satellite can fail. This GPS will not work. So this is a additional satellites. Those information are there also will be sending. This is what we need. Your GPS receiver need this only. Okay. What is this? First two subframes are telemetry information, correct? Which is P code. This is meant for military purpose, accurate position information, also maintaining the satellite health, all this thing. The TLM word contains synchronization pattern, which is used for receiver to access navigation data. Then how HO provides the time information, which is the most important information to find the distance between satellite and the receiver. One distance is known for 3 satellites, then you can find the location of a position. Okay, please note that this is very important point. Okay, triangulation, how the GPS receiver is done. For example, this is my GPS receiver. I am circling, correct? The center one. Okay, and it is able to see 3 satellites, A, B, C, because this is Earth surface, correct? This is Earth surface. You are standing here, so you are able to see 3 satellites, right? This receiver receives 3. Now, you from this, using the time message information, correct? Time given delta t, you are able to locate the distance. This distance d, I said d1. D1 is delta t multiplied by c, where c equal to speed of the light or this one. So you know the distance. Similarly, you using second time information, you can find the d2, you can find the d3, correct? With respect to that satellite, you know the distance, you draw a circle. With the first satellite, you know the distance, you keep this as a radius. D is now become a radius, correct? So that means if we draw a circle, red color circle is done. Okay, now you know you are here with respect to the satellite, but exactly you don't know where on the surface. Why? Because you can be anywhere, because the radius says you can be anywhere in the circle, but currently you are here. So with one satellite information, you cannot know where you are on the Earth surface. Now, second satellite already found the distance using the radiation received from that. So you draw another circle with respect to that, the black color. Correct? You know that. Then these two, red and this are crossing here. So that means you know this location, but exactly you don't know where you are. Now, you know the third location. If you try to, correct? If you try, why? When you have the third location, you draw another circle. The distance already you call D3, which is nothing but R3. You draw a circle with a radius. You see that this one cuts green one. So now with that you are able to, where all 3 circles are intersecting, correct? That location gives the precise position where you are, correct? So that's why you need 3 satellites. You find this. Now, this is how you find this method is called trilateration. Correct? Having 3 distances from current location, then drawing 3 circles where all 3 circles are meeting. That point is your location. So now for each location,
one thing I want to ask: the point can be obtained by just intersection of 2 circles only. Why third circle is required in that way?
Yeah, the third circle overlapping is needed to find the all 3 positions. No.
So with 2 circles only, there will be 2 points. Which one to be chosen? We need to check.
You can be here. These 2 positions. See, you take the 2 positions, right? If you have 2 satellites, who is that told that the 2 positions? 100% correct. Because yeah, see the red set. This is you have only 2 red and this one. So it is intersecting here. Here also it is intersecting.
Okay, got it, sir. Thank you.
Two positions, but where you are. If you want to finalize, then you need a third satellite. That's why you
Right. Thank
now,
you.
if it is for 2D, in 3D means height also, altitude also, you need 4th satellite also. Okay, this is how the satellite calculates. Receiver, it sends a time information. I told you, time message is some TA information. From that, the distance is calculated. As I told you, correct? This is a time, a transmitted time, correct? B is called receiver clock bias, correct? If there's any, you know that GPS uses the clock is atomic clock. but receiver doesn't have atomic clock, your cell phone, all those things, correct? So bias will be there. That is also sent by this one. So TI is the time message of reception, is nothing but time transmitted minus bias. One that is known, this is what T minus the received is SI, satellite time, correct? This is received time. This is the time at which satellite has, SI is the time at which satellite has sent time, that message. You know the difference. Then multiplied by C. C is not speed of light. Speed of light, which is nothing but speed of the GPS signal, because the electromagnetic signal. So you can calculate the position from each this one. Then you calculate the radius, the distances. Then draw the circle. Then you know the position. This is how it works. Okay. There are many errors are there. All this the correction. Just understand this is sufficient. With this, you know where you are. Next thing is the path planning, correct? Hierarchy of decision making process called path planning. Highest level we saw that. For example, I am here. I want to go here, correct? So now there are 4 roads, intersecting roads are there. I can travel from here to here using this path, or I can travel like this also. There are 2 possibilities are there, correct? One is already shown, other one can be like this. Which one to take? You are here, you have to come here. Why? Right? So route planner, what it does is select whichever the best path is possible, shortest path. Right? Okay. You see that this will be green one will be shortest. But if there's a road construction obstacle, so for example, your GPS, this one, no map, it says that there's a road construction, heavy traffic, take this. It gives alternate, but it says the longer distance. So like this, you can do the first thing is route planning is the highest level. I want to go from X to Y, what path to go. Then next comes the behavior layer. In behavior layer, right, what type of maneuver you have to do as a vehicle, right? So negotiate intersection, parking maneuver, or unstructured environment, road is not good, change lane. These are called behavior. As vehicle is moving, vehicle can do any of these things, behavior, vehicle behavior, right? So human driver will do this, right? If the negotiation, if the intersection is there, he has to negotiate, correct? Wait for the red signal or the green signal. Lane he has to follow, correct? If lane there's obstacle, he has to change the lane changing. Like this, this is called a behavior planning, correct? Well, then comes to motion planning, actual vehicle motion planning. Estimate the pose and the collision free space, correct? So actual vehicle, this one. Then finally, what you call as local feedback control. Correct? You are supposed to go in this line, but currently you are here. So what do? You will correct to see this come and join the road. This is called a final local feedback. So therefore, route planning, behavior layer, motion planning, and final feedback control. Okay. So route planning, the highest level, vehicle decision maker must select the route through which road network from current position to requested. That's what we are talking. From here, I want to go here. Whether I go like this or go like this. That is the job of the route planning. As I told you, there are 2 paths. Which path to do this one? That also decision taken. Correct? If I want to travel, what I do? I see the map. I say the Chittoor road is free, but the road is not good. Correct? To Bangalore. Vellore road is good, but lot of traffic. So I take a decision. Autonomous vehicle also has to take a decision, route planning. Once you decide a planning, then it has to go to behavior, this one, then motion planning. Okay. Behavior planning, what it does, vehicle must navigate the selected route and interact with other traffic participants to driving convention and rules of the road. Correct? So red signal, green signal, lane following, all this thing is the driving convention. This has to be followed. Who is going to do that? The behavior layer. Right? We say the 4 layer. This behavior layer job is that. Correct? Given the sequence of the road segment, I told you a road can be straight, a path can have many segments, curved segment, again one curved and something like this. This is my destination. Correct? Straight line, a curved segment, again one more curve, again one more curve, then straight line. That's what we are talking. Behavior layer is responsible for selecting appropriate driving behavior at given time, whether it is straight line driving or curved driving. Accordingly, accelerate, decelerate, what should be the speed, all these things. If you speed limit, all these things. In curve, you cannot go to higher speed. Correct? All those things will be decided. What speed the vehicle should take a turn. You know, as a human driver, correct? But an autonomous vehicle, you know the CG, what is accepted, all these things already known. Based on that, you have to, if curve is a curve based on curve radius, all those things, the vehicle controller should automatically adjust the vehicle speed and steering angle, rate of steering, all those things will be done by this layer, decision making layer. Since both other parts of what they are doing, correct? Any intersection, other vehicle, everything you have to monitor. Since both driving concept behavior each model, automating this driving action is a model behavior, which you call a state finite machine. Because I'm just giving the information because what is state finite element, state machine, all those things, another area that is generally implemented using this finite state machine decision making algorithm. That's what I just want to say. Then motion planning. What is job of motion planning? When behavior layer decides driving behavior, perform the current concept, whether you cruise in the lane changing, turn right, or anything is selected, this is motion planning is done. The next layer. The behavior has to be translated into path or trajectory. As I told, whether a straight line or curved or a spline, correct? And accordingly, the low-level feedback should be given to the controller, which corner the ABS, steering control, as well as engine control, correct? The low-level feedback. The resulting path or trajectory must be dynamically feasible for the vehicle, comfortable for the passengers, and avoid collision with this one. The speed what you are selecting, correct? Dynamically, what acceleration, decelerate, what velocity you have to maintain, what should be steering angle. You cannot take very sharp steering angle, but if the radius of curvature where road is there, you have to take, whether it will be comfortable for the driver, correct? If you over acceleration, correct, people may not like the, correct, that is called ride quality, ride comfort. All these things should be taken care. Task of finding such path and trajectories is responsible motion planning system. What we are talking is this motion planning, correct? This is the third layer. Finite state machine coupled with different heuristic specific considered driving scenarios were adopted as a mechanism for the behavior control. Because this is a topic, just I'm trying to say, correct? A lot of things are there. So real world driving, especially urban setting, however, characterized by uncertainty, intense other travel. That's why the autonomous vehicle driving in city traffic, what other pedestrian, correct? Huge traffic, bumper to bumper, how they will behave, how the prediction, all this thing very difficult. Because there's no gap between you and the other vehicle. In highway, we know the inter-vehicle spacing is there, 10 meter, 20 meter, depending on velocity. In city condition, not possible. That's why autonomous implementing in city condition very difficult, we are saying. Correct? Numerical approximation methods are used for motion planning. Finally, vehicle control. Vehicle control is to a reference path, trajectory for the motion planning system with a feedback controller so that the vehicle follows the actual trajectory. That's what we have shown here. Correct? Actually, vehicle has to go in this direction, but vehicle is already deviated. So it has to correct itself and come and join. Right? That is final local feedback. That's what we are talking. This layer is make the vehicle to follow the intended path. In this case, intended path, this is a black color line is intended path. Right? But now it is deviated. So the final local correction in the vehicle control, steering and brake together, your engine control, you see that vehicle comes and joins the actual path. This is job of this one. Okay, ensure error, execution, motion planning will be this one. Robustness and stability of vehicle is very vital in case of vehicle control. Otherwise, vehicle may not follow the actual this one, accident can happen. Okay, when we talk about this one, we talk about what you call a trajectory generation. Correct? Trajectory generation is, we say that vehicle already the route planner, right? The route planner says is a straight line and this is a curved line. correct? So this is called as this segment is called trajectory. It is a straight line trajectory. This is a curved trajectory, right? So a road may contain straight line, curved, spline type of trajectories that you have to generate, correct? So for that there are algorithm available, trajectory generation algorithm, which will generate the required whether straight line trajectory or this one, and what speed it has to go, whether it accelerate, all this thing is done by trajectory generation software. The trajectory generation problem can be posed as a 2-point boundary problem, right? We have the initial position and final goal position with system dynamical. This is a function, correct? Add as a constraint, correct? X is dynamic function, which is a function of X starting and ending position. But and again, in this, what is important? What time? See, current position from here to here, I say the 100 kilometer, right? And this should be traveled within say 90 minutes. Then the velocity comes. At what velocity? We know the distance, you know this one, time, right? From this, you can find dynamic, what should be velocity of the vehicle, correct? Which is function of initial and final positions, correct? And that's what called physical constraint. But one constraint I am talking. Trajectory is defined as a infeasible if there is no control input ut for a given state trajectory which satisfies boundary conditions, correct? So it is a function of X and this one. If you cannot generate control input for the given this one, U of t is nothing but a control input, right? If you cannot generate, then we say that the trajectory is not possible, correct? You say that there's a curved trajectory, you say that your vehicle has to go 60 kilometers. In that case, the vehicle will go away from the trajectory. Not possible. All those things will be checked by the trajectory generation software before generating command, correct? Trajectory generation is going to generate what should be the vehicle velocity. That means that will go to the ECU of the engine management system, correct? And what should be steering angle, that will go to the this one power steering system controller, like that we do. Trajectory is a response of the motion combined with some time travel. That's what I told you, correct? So which decides what should be velocity, acceleration, all these things. So these are the constraints. Trajectory, there are two types. One is called sensor based and vehicle dynamic based. Sensor based approach is generally concerned integrating the perception with the environment, making vehicle dynamics into account. Vehicle dynamics approach generally takes into vehicle mass and inertia, so that what should be the maximum velocity, what should be the maximum acceleration, that all those things is considered. So whether to use this method or combine these two, correct? So there are many optimization methods are there, so that optimal trajectory or path is generated, correct? So all those things will be, so this is trajectory generation software will do this. There are two methods, one is called geometric method and model based approach method. Okay, that is sufficient right now for you to under this one. So we will talk about geometric based a lot. Okay, as introduct this one, I'll just talk about geometric based. Geometric based path tracking is algorithm uses geometric relation between to derive the steering control. Basically, we think that in this case you are going in constant velocity. Of course, please know that you'll weigh while going in one segment, you maintain a constant velocity. This is an assumption you made, correct? If you don't have assumption, it is very difficult to drive the vehicle. But you are doing internal assumption. As you see the road, if curvature is not there, you know the straight line, all this thing you do, same thing only. In geometric code, in this case, for example, velocity is constant, correct? Then you are going, that means the accelerate, deceleration is not done. You are going to control only steering so that you follow the given path. That's what you say, geometric code, steering control law. This technique utilizes look-ahead distance to measure the error ahead of the vehicle, and the complexity range from a simple circular path or calculation to sophisticated geometric theorems, such as pure pursuit method. Okay, pure pursuit method, carrot chasing method, there are the different methods are there. Geometric path tracking pursues a point along the path that is located at a certain distance, look-ahead distance, away from the vehicle current location. Okay, this algorithm is relatively simple and robust to implement. Pure pursuit, other one is called carrot chasing. These are very simple algorithm to understand. This is also used in an autonomous vehicle. We will talk about it. Input to the algorithm is always waypoints rather than smooth curves, and therefore less susceptible to the discretization related issue. Correct? Then the algorithm suffers from corner cutting and steady state error problem if the looker distance become not selected properly. I'll come back to this one. First, there are many methods. Please note down, these are methods. I'm just going to talk only carrot chasing. Just to another 20 minutes will complete. Pure pressure, non-linear guidance, all this thing you can see in the literature books for future. Correct? I'm not going to talk about it. These are the different methods. Carrot chasing is simplest, then pure pursuit, non-linear guidance law, NLGL, vector field approach, linear coordinate regular path. These are the methods there. So what is whenever you talk about path planning, there's a path following problem. What is a path following problem? Given a path with initial location P, correct? We are talking two-dimensional. That means X and Y, correct? Vehicle going on the road, correct? It is only planar X and Y along with a heading direction. Okay, which is given here. Psi. The path problem defined is to determine the commanded heading angle psi d for the vehicle such that by following psi d, the vehicle will accurately track the path as the vehicle moves towards destination. This is called as, see, your vehicle is current location. This is explained here. The path can be a straight line or curved path, correct? The straight line path can be defined as a two waypoints. Okay, Wi plus 1. This is Wi, correct? See this graph. Wi is the initial point. From here, it has to go to this point, right? That means it has to go like this. This is the path it is supposed to go. Okay. Now, starting position, ending position. This is the path it should have taken, right? But what happened is the vehicle moved in this direction wrongly. Currently, the vehicle is at this location. This is your vehicle position P. Okay. And apart from that, the vehicle current heading direction like this. It has moved this one. You see the arrowhead direction. It moved like this. Currently, it is slightly rotated, looking like this. This is a velocity vector. Correct? Vehicle is looking like this. And but actually, where it has to be, it should have been in this point Q. It should have been come here, Q. But instead of that, it is in the location P. So this D is called the deviation. From the originally it should have been now, but it is looking here. Now, what it has to do? It has to go here, right? First thing is this has to be corrected. The distance has to be corrected. But if you your vehicle can this one turn this much, you know that vehicle the turning angle is only 27 to 30 degree, correct? So it is looking like this. That means you cannot turn like this in given location. That is a limitation of the any vehicle, correct? Laterally it can, laterally it cannot move laterally, because this even if you steer, what it can do, it can take a curved path only. So basically it should come and align with this line, right? So that means you need to, from this current heading direction, it has to desired psi d. That means it has to turn like this. That is possible, correct? So now it rotates and start moving towards this and reach this point S. If it reaches S, then it can continue this. That's what we are talking. This algorithm, path following problem is, it has to go from Wi to Wi plus 1 with some velocities was moving, but currently it has not this one. Now it has reached the location. You need to give a steering command, correct? This is steering control. Psi is the steering angle, such that from the current psi, it has to go to psi d. This is desired. That means it has to turn like this and move straight line, and will come here. After that, it can follow. So the straight line path can be defined as two waypoints, because my vehicle is supposed to go in a straight line currently. Current segment is straight line. W is this one. We call this two waypoint. The angle formed by waypoint is called a line of sight angle, right? It's called a line of sight angle. You can see that this angle, because you're being a planar, this is x-axis, this is y-axis, right? So with respect to x-axis, that's also in x and y, right? So if I wanted to go straight away, what should be the angle? Theta. That was the original desired, right? They call line of sight angle. But presently, it moved in theta u, correct? You can see here this angle. So because of that, it reached this location by mistake. And currently it is looking like this. It reached and the current heading angle is this. Now, we assume that d, the distance d, what is this distance d? Is the actual distance d is from the actual path. This is the actual path. And the path followed was this. The d is called as crosstalk error. Right? They're called crosstalk error. Right? Crosstalk error. Actually, we don't want, but it has happened. How will you correct this? That means, and the crosstalk, the vehicle controller must ensure that the heading angle psi is same as LOS. Right? This currently it is going in this, but after reaching current heading angle is this. But what I want is theta. Correct? Theta is the correct angle. But right now it is different. So the objective of what is the path following algorithm should do? Currently this location it has to correct. For that it has to minimize the d. Correct? The deviation is too much. That should be reduced. How will you do that? And also see that the psi minus theta, right? Such that both tends towards 0. The error, this should be 0. This also should be 0. Correct? Currently there's a deviation. The deviation is not acceptable. Correct? When it becomes 0, automatically reach here. That's what we are saying. Similarly, if the psi minus d intended minus the current heading is this, that also should become 0. This should become 0. This also becomes 0. Correct? To make it, what you have to do, you have to control the steering angle. That was psi d. Right? You adjust psi d such that these two become 0. Right? As the vehicle is moving, tends to 0. And you cannot happen, it takes some amount of time. Right? From here to move here, you need some amount of time. We say that as t tends to infinity, right? Then these two should be minimized. This is called optimization problem. Path following optimization algorithm. Okay. So this equation you forget because I am not this one. This was done for something. So I will just take these two slides. Right? We understand what it is. Correct? This was one of the research problem of my PhD scholar date. We don't have time to discuss about it. Don't worry about that. So this is a path following problem. The whole idea is this: to achieve this. Right? There are many algorithms we saw. These 5 algorithms are there to solve this problem. Right? So that vehicle reaches this, goes to final destination. For that, I will talk about carrot chasing algorithm alone. Right? The simplest approach to follow the desired path is introduce what you call a virtual target point, VTP. Okay. You see here, this is the starting position represented by WXI. I means initial. WYI with respect to this is X, this is Y. Okay. Now already we know that theta U, correct? Heading angle. This is desired head angle so that you will reach here. Now already we have, this is the cross track error. This error should be 0. And for that, how will you do that? What I introduce is, I introduce the point called virtual target point. Okay. Which is marked here as S. This is the VTP point. Virtual target. Please note that there is no such point on the road. But as a driver, if you are driving vehicle, already told in the beginning, correct? One time, what the driving instructor ask you to see some 100 meters away far. You don't look closer, right? If you look closer, you'll be continually adjusting steering wheel. You should not do that. That distance. This is the point. and you called as virtual point, VTP. Okay. So as the engagement progress, path eventually will follow. VTP point, if you reach the VTP point, that means current heading angle is psi, desired angle is this. If I turn for psi is considered, so that you will look ahead and go and reach the VTP point, right? Virtual point. That's what the whole idea. Because currently you are here looking like this, right? You change the angle, steering angle to theta d, psi d from psi, and look at this point and move straight, right? Then you'll reach this point. From there, you can move towards this. Okay. So as an engagement progress, vehicle approach towards the eventually reaches. First you will reach this point, then finally you will turn and reach the final waypoint. In this approach, VTP is called as carrot. Correct? You know that people would have done previous. No, this is generally told us if you have a donkey, correct? Generally, the carrot chasing or a horse, they like eating carrots, right? So you have a bullock cart, right? You have a bullock cart axle, right? Driven by a horse. Okay, I'm not drawing horse properly. What you do is put a long stick, hang a carrot, right? So this it wanted to go and eat this. So what you do to catch this, automatically horse or donkey will run. So this is why there was carrot chasing algorithm. So here, what is it? Carrot chasing algorithm here. This vehicle is here. It has to turn and go this place. This is a carrot. VTP point is nothing but carrot. The idea of the autonomous vehicle driver is to look at that reach, which is away from the distance D. The VTP point is away from the current vehicle, and the S is sitting on the actual path which you wanted to do. Right? So that's why we call carrot chasing algorithm. Because this is a straight line following, correct? So determine the crosstalk error D. First thing is you have to find out what is D value. Then updating location of virtual target. This is virtual target is xt, yt is here because of plane. These two have to be done. Let the crosstalk error of the path is under the VTP is given as D, correct? And the distance between, correct? This point is Q. Actually, if you are travel in this direction, you will have reached Q, not the P. By mistake, because vehicle has moved like this, because the angle has changed. Instead of theta, your vehicle was moving with a theta U. That's why it reached this location. Okay. Now, what is delta here? Delta is the distance between the actual point the vehicle should have reached and the VTP point. Correct? So this distance is going to delta. And the cross track error is mentioned as D. Okay. Now, what is that? If you want to reach this point, you are supposed to have psi D, that is desired angle. Vehicle desired heading is updated based on the S location, this location. Okay. This is what the algorithm is doing. The process of finding new psi D continues until vehicle reaches this current final location. Okay. So what we are doing is, because you know that you cannot suddenly turn. You understand? The steering angle cannot be abruptly changed with psi to psi D. From here, you cannot change. So what you will do is, you will adjust the steering angle such that it takes a path. I will draw that. Right? So it will not be able to suddenly turn and go, because this is a lateral movement is not possible. Vehicle will start moving something like this and reach. So what you are doing, you are adjusting the psi to reach the psi D. When it reaches, it becomes psi D. Continuously adjusting, correct? Finding new psi D as the vehicle is moving from different location. Current location, it was here, it was going here, it is going here, it is going here, it is going here, it reach. So what you are doing, psi D is calculated and that is steering angle adjusted so that vehicle takes a path and reaches. This is what the carrot chasing algorithm going to do. That is shown as algorithm. This is last slide. Sorry. You can see that I have drawn the graph again. How will you do this? S1. There are many steps. First, initialize the values. Algorithm. initial value, you have to initialize initial position, final position, PXI, because this is you have to write a program. Carrot chasing algorithm, write a program so it can generate the path. Which path? This path to move. It is going to generate the psi D. This is given to steering controller, steering motor. So the vehicle start moving and reaches this location. Okay. So that is algorithm. Psi is this angle. How will you calculate? A tan of PXY, PY initially, right? Then RU is this distance, RU, correct? If you can calculate using this value, correct? Once you know this value, correct? W is the, okay. This parameter alone, I will tell you what it is. For that you need this figure. You can see that this is a vehicle, right? So W is nothing but distance between back wheel distance between two back wheels, right? Then the distance between front axle and the rear axle is WB. W is this, WB is this, right? And this is psi is the current heading angle. Okay. R is the turning radius, right? If you draw turning radius is this. We think that with respect to this, if the vehicle is rotating, if you draw this one, circle, correct? As a radius. Okay. So that was the radius, turning radius. R is turning radius. This is wheelbase, the vehicle velocity VA. Here put as psi, right? Same thing only. It is a capital psi. This is the small psi in Greek letter. Okay, then you can calculate this. Finally, you will get the omega. Basically, what you need is, this is nothing but steering angle, correct? K into alpha. Alpha is the orientation error. That is the angle difference between. See, the picture gives very clearly. This difference between this and W psi D and psi is called as alpha, correct? Orientation error, correct? Then you can K into alpha is given as, the K is a gain. This is a controller gain. Right? You can change the controller gain. Okay. Now, carrot chasing mainly what I am talking is, for example, vehicle was here, correct? It is supposed to go in the red color line. Now it is here. It has come here. From here, it has to come to destination. This is starting. This is the end location. Correct? Instead of going in the red line, it has taken. Now, if I apply the carrot chasing algorithm, depending upon delta, correct? Delta is 0, delta is 10, delta is 30, delta is 50. What is delta? Delta in this equation, you can see here, this distance. This is look ahead distance. Right? Delta, this is error between, if the vehicle is here and the way, this one waypoint, right? This is distance, called as a look ahead distance. If you vary the look ahead distance, you can see that the vehicle will have different path, right? So one is solid line, another dotted line, other one is dot plus broken lines, right? So which one is better? If this is not good, correct? Vehicle passenger inside will be, vehicle is moving like this. This is not good. Next one also, you can see that it goes like this. There is a peak, they call peak overshoot, correct? So the best line will be going from here. If it takes this path, gradually reaches and merges with the actual line and continues. So that means delta equal to 50 is better, right? The path parameter, which is called a path parameter, look at the distance, can be modified the performance of the carriage as shown in figure 0 to, we have varied up to 50, sorry, 0 to 50. sorry, typo mistake. The vehicle is forced to move towards LOS. And LOS line of sight. This is line of sight, this one. And it takes longer time to settle, resulting from the crosstalk error, right? For different gate. So this is how the carrot chasing algorithm works. Stop here. Sorry, any doubts?
Sir, I have a question over here.
Yeah.
Sir, basically, the carrot chasing algorithm, it will work when the vehicle is deviated from the path, right, sir?
Yeah.
Or it's a continuous operation while the vehicle is moving around.
No, if you deviate, you are correct. What is the idea of the whole thing? You have to follow the particular trajectory.
Right, sir?
Steering trajectory, no issue. Correct? If the steering, please know that there can be deviation in the steering. Correct? If you deviate the hand steering, correct? If there's a wheel has some what is that? It can drifting can happen. No.
Okay, I was wondering if we have vision camera installed on the vehicle,
Okay.
lidar is there. Every vehicle is equipped with every possible vision
You are continuously adjusting steering. No. What is that you are trying to